of area, where S is the length of a side and area is the number of square feet in the room. Include one decimal in your answer. So what do we know?
In 1/9.
A contractor ordered 135 square feet of vinyl tile for a square room.
All right, 1,355 square feet. Do you think this square part is important?
Yeah.
It does, right? Matters. All right.
And then the formula.
And then the formula. So we've got a formula down here. What are we trying to find?
Square root of area.
Okay, all right. So we're trying to find the length of one side, right? Which is exactly the square root of the area. Okay.
Mhm.
So we want to find S. Oh, I was going to change the program here. We want to find S. Like you said, that's equal to the square root of the area. So I have a feeling, did you try this, Victoria, and you got the wrong answer? Like, did it tell you?
I did it.
Okay, it might be a calculator thing. So if we know there's 1,355 square feet and we have the formula and we want to find S, that's what we're trying to find. What are we going to do? What do we have to do?
Wouldn't you?
Wouldn't I what?
Wouldn't you put 135 in the area?
Yeah, 1,355, right?
Yeah.
Right. So my area is equal to the 1,355, right? And that is feet squared. I'm going to write it like this on purpose. So if they plug that into the equation here, right, then it's the square root of 1,355. And we're also taking the square root of the unit here. That's feet squared. So then if you plug that in your calculator, what do you get?
It's the same answer.
What do you mean? So you have to find the square root key on your calculator, right?
Yeah.
And you take the square root of 1,355 on your calculator.
1,017.8225.
Something's weird. So are you using your phone for your calculator?
No.
You're using a regular calculator?
Yeah.
Do me a favor and hold it up to the camera. And there. Okay, so leave the square off. Just take square root of 1,355. Don't put, are you putting a little 2 in there?
Yeah.
Don't do that. So just do the square root button and put in 1,355 and hit equals.
Oh, doing the wrong number. God. Okay.
Then what'd you get?
336.81032.464.
Yes, much better. Much better. So yeah, I think where you're getting confused is because the units have a square, right? So you were putting a little square after it. So then you just end up getting 1,355, right? Which is probably very confusing. But that square is just applied to the feet. That's only for the feet part, not for the 1,355. If I split this up, what happens is we're taking the square root of 1,355 and we're taking the square root of feet squared. Okay, so it's a separate thing. This one here is where we end up getting that number that you just told me, the 36 point blah, blah, blah. Here, when we take the square root of feet squared, what do we get?
Feet squared.
We're taking the square root of the feet squared. There's really...
Feet cubed.
Nope, go the other way. What happens is the square root, They really has a little 2 here. That 2 and that 2 cancel each other out.
That's just feet.
Yeah, and you end up with just feet here, right? Because if you think about it, what we're trying to find is side length, right? And side length is really in feet.
We don't include the unit, right?
I do not believe so. I don't even think it will let you.
I'll do one with the unit and one without. Just
I'm gonna check.
yeah, double check on that.
I'll grab the next one anyway. Nope.
So 36.81 is the answer.
1 decimal, it says.
3681.
1 decimal.
I put 1 decimal.
You just told me 2 decimals.
36.81.
0.81 is 2 decimals.
Oh, so it's just 36.
1 decimal. 1, you can do it.
Wait, it's 0 0 at the end?
Have a hot dog.
I think I should go get one.
I know. See, don't do math hungry. It's bad. The 1 decimal. We did this last night a bunch of times. You're tired already. 1 decimal.
Yeah, my brain is fried.
No unit. I'm gonna let you work that out. 1 decimal, no unit. All right, I'm gonna grab number 6 here.
Is it 36? Is it just 36?
No, you need 1 decimal. So 1 number after the decimal.
0. No, 0.8.
Yes, 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 yes.
God.
If I get you to slow down 10%, you're gonna be dangerous. All right.
I'm dangerous.
Mark told me to stop signing, Heather, because he's not quite ready.
Okay. All right. Number 6 is the last one for the week 4 quiz. Unless somebody else has a question.
And then for number 10, wouldn't it be 07.77?
Let me check.
Can you double check that one?
Shall. Number 10. What was your answer?
0.077.
No.
Can we do that one? Because I was confused about that one when I was coming home.
Yes, and I'm gonna razz you about that one. We did this last night a couple times.
Oh my God.
It's all right. You can handle it.
No, I can't.
Yeah, you totally can.
Is it where this piece of paper came in handy?
Yeah. Okay, number 6. Let's look at number 6. What is the mass of an object in motion if its velocity is 3 meters per second and its kinetic energy is 180 joules? Use the formula KE equals 0.5 mv squared. The answer will be in kilograms, and enter your answer in the nearest whole number. All right. What do we know?
You ain't not sharing your screen.
Oh, that's something we know, isn't it? Thank you.
I'm like, why do I see a big fat face?
All right, let's try again. What do we know?
The kinetic energy is 180 joules.
Kinetic energy is 180 joules. All right. What else do we know?
And then the velocity is 3 meters per second.
Right. Okay. 180 joules. Velocity 3 meters. Whoops. 3 meters per second. What else do we know?
The formula.
The formula. What are we trying to find?
One second. 1 second. The answer would be in kilograms.
Right? And what is that? The unit's gonna be kilograms. What is it that we're actually trying to find? We know KE, right? We know KE, kinetic energy, and you told me that we know V, velocity. So what is it we're trying to find?
Mass.
Mass. We're trying to find mass. Right here it says, what is the mass? Okay, and you're right. We're trying to find it in kilograms. Okay, so we want to know mass. And it's going to end up being in kilograms. This is one of the, I had this in the webcast. I talked about joules in particular being it's kind of a nickname for a bigger unit. So joules is really kilograms meters squared per second squared, which is a pretty weird unit. But that's okay. But writing that over and over again can not only be cumbersome, but it also is easy to lose parts of it. So if we nickname it joule, then it's easier to track. So everything does cancel out nice and neat, like brackety. But joules, we just realized that joule's a nickname. Okay, so this means that this particular one, we have to solve for mass, right? Which means we got to move some stuff around because we want M, and the formula, the way we have it, has KE equals. What we want
is mass equals 0.5.
Yes. Yeah, we want mass equals something, right? So we need to move everything away from that M. All right, so this is in the videos, I give 2 different ways to move stuff around. One I call the swing method, and the other way is to think of how can I cancel out things. I don't know which one you prefer. Do you know which one you like better? Does anybody got a preference, or do you want to see it both ways?
Both ways.
All right, we'll do it both ways. So I need to get M by itself. So because this is all multiplication, this is really 0.5 times mass times velocity squared.
Yeah.
Right? There's really an inherent little times between all of those things. I don't have any plus or minus. I don't have any add or subtract. That makes this a little easier. And it doesn't matter whether I move the 0.5 first or the V squared first.
Okay.
I do want to move the square. I'm going to color that in here. I do want to move the square with the V. Okay, V squared is going to stay together. So what do you want to move first? Do you want to move 0.5 or do you want to move the V squared? Anybody care? Got a preference?
I think the 2 squared.
Move the V squared first?
B squared, yep.
Okay, sounds good. So the cancel out method is what can we, okay, so we'll move the V squared first. The 2 methods are this. One is we can cancel out the V squared on this side by forcing it to be 1. So what could we divide V squared by?
What? I think you froze.
Yeah, we just have to stay put one. I was on block. Oh, there she is. Okay, good.
I'm back.
I thought you said it was better.
Well, it was, and then well, I warned you, it dumped me out. So I switched to my cell phone, and hopefully last night it was much more stable on my phone.
Yeah.
Fun when it just kicks me out and I'm talking to myself.
I'm just like, why is it
Okay. Yeah. How far did we get? We were here. We're gonna move b squared, right?
Yeah,
All right.
that's how far we got before you got kicked.
Where I got dumped out. All right.
Yeah.
There we go. Okay. Okay. So the first method is to cancel out the thing we want to move. So what could I divide v squared by to force it to be 1? So v squared over what equals 1 is my question.
65.
Wow, that was random.
There was
V
a
squared.
1 there.
So here's, yeah, there is a 1 there. Here, I know it's 65. You're going to remember that forever. I'm doing it just because you said 65. 65 miles per hour, right? Let's just use the number 65. 65 over what equals 1? 65
So-
over what?
So b
What'd you say?
squared? So they have to be a square? The same
No,
thing?
this is, yes, v squared. Yes, Juan, got it, right? Because
Yep.
anything, because 65 over 65 equals 1. So just because it's a letter doesn't mean that the rules change. V squared over v squared equals 1. Perfect. All right. There, I worked 65 in there just for you guys. Okay, so if this is true, that means that we could divide this side. I'm going to divide this side by v squared. What happens is this becomes 1.
Mhm.
And if I do that, I accidentally erased my KE. If I do that, I must do the same thing to the other side. That means I have to divide this side by v squared. Okay? All right, so that means where I'm at now is I have KE over v squared equal to whatever's left over. Well, the v squared and v squared have now canceled each other out, and I just have 0.5 with the m left. Okay, here's my m. I'm going to color code it so we can keep track of it. So now we're almost there. Now I have 0.5 m. I need to move the 0.5 away from the m. To do that, I need to divide 0.5 by something that forces it to be 1. What can I divide 0.5 by to equal 1?
0.5.
Yeah, exactly. Perfect. Right? So now we divide this by 0.5. Whoops. I could get my mouse action going here tonight. Divide that by 0.5. That means I also have to divide by 0.5 on this side, which means that S is going to end up being on the bottom over here. My 0.5s on this side are going to cancel, right? These are going to cancel out and become 1. Now I have KE and over 0.5 times v squared equals m. Now, I don't know if anybody got fancy and moved the 0.5 to the top. The way you do that is, this is 1/2, right? 0.5 is 1/2. Well, if there's 1/2 on the bottom, it's really 2 on the top. Just in, you did not have to do that part, but in case anybody ended up with this, or you run across this formula, they're the same thing. A 1/2 on the bottom or a 2 on the top is the same thing. All right, let's do it the other way in case that clicks with somebody, and then we'll plug in the numbers. Okay, here, I'm gonna put it down here. The other way to do this is what I call the swing method. I'm big on having more than one way to do something because sometimes it clicks one way for half the class and the other way clicks for the other half the class, and it doesn't really matter. All right, so we started with KE equals 0.5 MV squared, right? So another way, and you might have learned this before, sometimes people are familiar with this one, is that everything is all about the equal sign. Everything is a balance for the equals. If you do one thing to one side, you have to do it to the other side. So the swing method, we pick the thing we want to swing over. I want to swing the V squared over first. So if I swing to the other side across, and I cross that equal sign, that means that it goes from the top to the bottom. So I would know that the V squared would automatically go to the bottom because when it crosses the equal sign, it has to switch. So multiplication becomes division when we swing. So if we swing the V squared over, I just know that that goes to the bottom and I end up with KE over V squared. So we're in the same spot we were in with the other way, 0.5 M. Now I do the same thing with the 0.5. I swing it to the other side. On the right, it's a multiplication. So on the left, it becomes a division, which means it moves to the bottom. All right, that's the swing method. And then you end up with just M by itself. All right, because the 0.5 goes away, then we end up with KE over 0.5 V squared equals M. So it's the same thing, it's just a different way to think about it.
I got totally lost.
You got what, Juan?
I got lost.
You got lost on which one? Both of them?
Why we moved the 0.5?
Because all we want by itself is M because we're trying to find mass. So we need that little M to be by itself in the equation. Another thing that sometimes helps students with this kind of problem, if you struggle at all with the algebra, is to plug in your known values. So if we started out with KE equals 0.5 MV squared, this might help you, Juan.
Mm-hmm.
We would plug in our numbers right away. Well, for KE is 180 joules. So I would have 180 joules equal to 0.5. And then my M comes next, but it doesn't have to. So I'm going to move it around a little bit. That'd be 0.5 times my V squared, which was 3 meters per second, times M, right? So all I did here, instead of moving anything around first, I just plugged in my values first. So the M is going to be the only thing I have left as far as a letter.
Now I got it.
Okay, good. All right. So now let's just leave the unit labels off for a minute because now this is 180 equals 0.5 times 3 times M. So we get 180 and we can combine the 0.5 and the 3, right? 3 times 0.5. We'd have 1.5 times 3. Yeah. 1 point because it's 0.5 times 3.
Yeah.
And then that's times the M. Now I can see that to get M by itself here, I just need to move the 1.5 to the other side. Okay. What can I divide?
Now we have to divide with the 180.
Yes. Yeah. No, leave 180 where it's at. Yes. Divide by 1.5, right? Get rid of the 1.5.
1.5.
Yes. I'm going to divide by 1.5 here. See how that will go to 1? That will become 1. And I can divide by 1.5 here. All right. Does that make sense? This cancels out, becomes 1. And then I just have m is equal to 180. 180 over 1.5 equals m. And now we have our answer.
But it says enter the answer to the nearest whole number.
So what do you get?
120.
Okay.
Is 120?
That sounds right to me. No, wait. Yeah.
Yeah, it is.
Yeah. So you get a whole number anyway, right? Out of this.
Yep.
Yeah.
Yeah. All right. That's a good one.
I was looking at it today. I'm like, what do I do?
No, that's a challenging one. You know, what I see is students who think algebra is kind of fun and easier have a more of a struggle with algebra, and vice versa. If you struggle more with algebra, or if you think algebra is easier, usually geometry is a little harder. I don't know why that is. I just know that from my experience, that's what I see. So, all right, cool. So number 10 says if the diameter of the drilled hole, yeah. Oh yeah. Got a question?
I'm sorry. So the answer is 120. M equals 120.
Correct.
Yes.
Okay. I just wanted to make sure. Okay. Sorry.
Yep,
I came in on the end of that.
That's all right. Thank you. Okay, number 10. It's all you, Victoria. That if the diameter of a drilled hole is 0.875 inch, what is the radius to the nearest thousandth of an inch? How do we find the radius if we know the diameter?
So we had the diameter, there's 0.875. So then we have to divide by 2. Then we got the radio already, right?
Right, and then we have to round to the nearest thousandth of an inch. How many decimals is thousandths? Yes, 3. Good. All right. So now tell me what you get. What do you guys get for this one?
That one.
0.4375.
3 decimals.
Don't you that divided by 2?
You did do it. Yeah, your answer is correct. Now round it to 3 decimals.
We still keep that 0 though?
Yes.
It's 0.438.
Yes.
Yeah, it
Yes,
would be.
Right.
I was
Cool.
so off right there.
0.438. Yeah, I don't know what happened there with the answer you gave me earlier.
Damn. Mother.
Darn it. All right.
Yes. I did okay on it.
Well, now you're going to do great.
Shush.
I won't. All right. Last time I'm going to do this, I'm going to pull up. Gotta get rid of that.
Oh, it says I got that one wrong. That's number 6.
What'd you put in?
120.
Of course. Because I just closed it. Hang on. I just closed it. I gotta get back to it. Did you just do it? You just entered it?
I just sent it.
All right, hang on.
What I miss?
So Victoria, you're a little trouble over there.
Yeah.
100% trouble.
Why do I always have the freaking trouble?
Oh, what did
Okay,
we do wrong? Yeah, you're right. It's not
Heather, I do have
120.
a question for quiz number 5. Sorry about that.
Oh, good. Okay, good. What did we
Yeah.
do wrong here? We did something wrong.
Where do
I'm
you
just like-
find?
Oh, I know what we did. Oh, you can't see it. Hang on. Yeah, you're right, Victoria. It's not 120.
What's the answer then?
I'm not going to tell you the answer, but we're going to find it. Okay, hang on. I gotta share my screen again. Where did you guys go? There we go.
You quit buzzing phone. I'm gonna power you off.
Good call. Math class is more important. Okay, you should be able to see my screen again. Here's where we went wrong. We all did. I went down the path. I led everybody down the path right here. What did we not do right here? And we carried it right to here. What did we forget to do?
That. Oh,
What did we forget?
We have to do it when
per second.
no, we have to do it oh, how did it say squared?
Squared. We didn't square the
Yep.
3. We didn't square the 3.
Because we never put it in the bottom. We have supposed to put it in the bottom too.
Yep.
So
I
you
got
divide by,
lazy.
what,
So go ahead.
4.5 instead of 1.5.
Yes.
9.
Right. So this becomes 9 right here. So this is where we took our little turn for the worse. That's 9. Good thing you did that, Victoria, so that we caught.
Good thing I looked at my answer.
Yeah, I know that was good.
4.5.
Yeah, so this becomes 4.5. And here we have 4.5, and here we have 4.5. So Victoria, if you need another chance on that quiz, let me know, because that's totally
That was my
totally
first
fault.
attempt.
Oh, okay, good. All right. Okay, so let's try it again. Now we should get something that looks more like, yeah, now we get the right answer.
Yeah, I got it. This makes sense right now.
Okay, good. That was,
So it's 40 now.
yeah. Our Mars rover, you guys, did not land on Mars. That's what just happened. We forgot to,
you let it happen.
if we were NASA, we would be in big trouble.
No, if you were the pilot, we would be.
I take all the blame. I own it. I should have got the square. All right. I think we killed this problem. Finally.
If it makes you feel better, it took me till the second attempt to get 42. So I got 120 the first time.
Oh, good. It wasn't just us. Yeah. It wasn't just
It's
me.
easy to do. It is.
Yeah, you get carried away and you leave
Yeah.
that little square behind. Dang it. All right. Okay. Mark, what question on the week 5 assessment do you want to look at?
Okay, hold on. All right, so we're going to continue and talk about 4. Are we done with 4?
We're done with 4.
We're
Unless he had a question about 4, but I think we're done with 4.
Yeah.
Yeah.
Actually, where is the book? What page number works with quiz 5?
There
Yeah,
isn't.
What
There really,
section of the book?
there really isn't.
Yeah, where can I study that information from in the math book?
All right. Let me show you some stuff. So we are pretty much done with the book at this point, because we do more trig than that book has in it.
Yeah, so that's it. I'm closing the book up. I'm closing it up, putting it away,
You
right?
can burn it in effigy if you want to. Just kidding. Maybe you don't do that, but
You can sell it on Amazon for $7.
All right,
sell it on
Oh my
Amazon
gosh. Oh my
for
gosh.
$7.
All right, so are we talking the Khan Academy and stuff, Heather? For the information?
Yeah, I'm going to go into the Canvas shell and show everybody what's loaded in there, so everybody kind of knows what resources are there and how to use them, maybe what order. I tried to put them in an order that makes sense to everybody, but so let me go there.
Okay, for the trigonometry. Okay.
Yes.
Yeah, for this stuff, quiz 5. Okay.
And then if you want, I can do a little overview first. And then if you know that there's a question or two on the assessment you want to talk about, we could do that after I do a little overview. I don't know if that works. Or we can go straight to the questions if you don't need that.
Yeah, whatever works, Heather. I think it's
Okay.
maybe
All right. So yeah, as I said earlier tonight, after tonight, we have 2 weeks left, which is crazy. So let me get my computer caught up with me. There we go. So the next 2 weeks really close down week 4. Week 5 was our midterm, which ends tonight. And then so week 6
Tomorrow night.
and yeah, oh, that's right, tomorrow night. Week 6 and 7 are really the same information. Okay. I just kind of, from my experience, trigonometry takes the 2-week window for us to really soak it in. So the week 5 assessment here, it actually says week 6 assessment. It's our 5th assessment, but I put it in week 6, is not due till March 9th. So I give you lots of time to do that, but know that the class ends that week. So you gotta, if you wait till March 9th to do your first attempt and you want to retake it, you're gonna have to do it kind of rapidly, but that should be okay. So let's just walk through what's in this module. The first video here, which is basically the same material I'm going to cover now. We're just going to talk through it a little bit. But this is what I call the Trig Toolbox. And so the Trig Toolbox goes with this Trig tutorial PDF document that's here. This is supplemental because the book does not have enough information in it for what we need. So I made my own. And then I already have the practice problems number 5 through 10. These aren't the assessment problems. These are just the practice problems. Number 5 through 10, I have worked out in a video. So that's separate from the toolbox. Questions 1, 2, 3, and 4, I don't have worked out in a video, but they are worked out on paper. You know, the PDF is applied down here. So here's the practice problems. Here's the solutions on paper. I have a video for number 5 through number 10. That's 5, 6, 7, 8, 9, 10. And then underneath that, which I might delve into a little bit tonight with you guys, is an explanation of where trig comes from. So you don't really need to know this to be able to use trig. But for some students, they really want to know, where did this trig thing come from? Because it seems so mystical and like weird, to be perfectly honest, that if they don't know where it comes from, then it doesn't make a whole lot of sense. So the unit circle is really where trig comes from, which is kind of bizarre to think that triangle trig comes from a circle, not a triangle. Weird, but kind of cool. So if you guys want to talk about the unit circle tonight, I'm happy to do that as well. So these are all me. These up here are me doing videos. Then there's the Khan Academy links, which are excellent. And he explains it a little differently than the way I do, and that's a good thing. So hopefully something in here resonates with like how you learn and how you think of it. And that's the reason for me giving you so many sources. I call these supplemental because if you didn't watch them and you watch this up here, you'd be okay. And probably the opposite is also true. If you watch the Khan Academy because you were sick of the sound of my voice, that would be also okay. The trig practice problems are really specific to this class though. So that one's kind of important if you're at all struggling with this. All right. And then
Yes,
of course,
I've been looking at that, but I wasn't following all the resources you provided. So from now on, I will look into that.
okay,
I
good.
will follow.
Right, good. Yeah, which is exactly why I'm going over it tonight, because we're just starting the trig now. So if you haven't watched all this stuff, don't worry about it. You have time to watch it. But and all of these are closed captioned. All of it. Khan Academy, everything's closed captioned.
Yep.
Okay. So then if we look into next week, you see it really is just repeating what we've already done. Okay, so this is not a different assessment. This is exactly the same assessment. So it's just keep working on it. Here's the trig practice problems. If you haven't watched that, do that. And here's the practice problems and solutions, and that's the assessment. So that's all the same thing. So those aren't two separate assessments. If you have completed week 4 assessment, you only have one more assessment to do.
Okay. And then does it matter what trig one we do? Or
No, if you
Okay.
click on either one of those, it goes to the exact same place.
okay.
Okay. So it's
Yeah.
just repeated. It's just a repeated link.
So you don't
And then,
see-
yeah. And then next week, and I'll be sending a email out to everybody in the class about this. So we might see some other faces in here next week. I'm going to go over, I will have a video posted explaining the final project, and I will also go over it in the Zoom next week. So I'll do both. I'll have it just like I did the midterm. I'll have a detailed video that's just me explaining the final project. And then I'll also explain it again in the Zoom for anybody who wants more of an explanation, like question and answer. That's my plan. And then we're done, you guys. It's crazy. Then it's spring. Math class is over.
So sad.
I love that you're sad.
What's the for week 8?
Week 8 is the final project.
Other project.
One more project. I gotta tell you though,
One
Juan.
more.
I gotta tell you, honestly.
Oh my God. I got
No,
crazy. I
it's-
got crazy for this week, like for the week 5. I spent
mid-
so many time to doing the.
So I hope this makes you feel better. Students always tell me that the final project is easier than the midterm.
It better be.
Yeah, the midterm's the hardest thing that you guys do in this class.
Thank God.
I shouldn't say hard. It's kind of detailed, right? It's really detailed. You have to
difficult.
be really specific. Yeah. So, but yeah, the final project is what students tell me is almost fun and doesn't really feel like they're in math class. So hopefully you will have that same attitude going out of the class, that you'll think it was fun. So it is a final project. I will open it so you have a week and a half to do it. Like you had the midterm, you had about a week and a half.
So when would you actually open the?
That means that I would open it. Hang on a second. Let me look at my calendar. By Monday, March 1st.
Monday.
Mhm.
For
That doesn't
week-
mean you have to start working on it then. Some people
Help
will
me.
want to. So you have a week and a half. And that also includes, you'll have both Zoom sessions. It'll be open by then. So I'll talk about it next week.
That is true. You will.
I will. I promise.
Is this just chat time?
Once I get, well, I was going to start doing some trig stuff. Do you guys want a break? Is that what you're
All right.
asking?
1 second. No, it's fine.
All right.
I
Everybody
could go
else
for a
doing
break
okay?
for. I could go for a break for 10 minutes.
Oh, Mark wants a break. How about we do 10? Virginia or Victoria, I just called you Virginia. Is that-
What does
yeah.
everybody else want? What does everybody else want? I mean, let's vote.
It's cool. Juan, could you use a break?
Yeah, that's fine.
Yeah, let's take 10 minutes. Jessica, if you want to talk to me real quick, we could talk but you could take a break if you need a break.
Nope.
All right. So everybody else take a break. Jessica and I are going to chat real quick. That'll work.
I need a mental break.
When everybody comes back, we will talk about some trig stuff. Okay, let
Yeah,
me
so I
stop.
have a question before you go to break.
Okay, yeah, what's that?
So week 6.
That was awesome that you just reminded me to record. Okay, so The Trig Toolbox, I use that analogy because then you can picture, you have a toolbox, you need a tool, you go in your toolbox and you find the right one. And often there are several tools that will do the same thing. And Trig is very much like that. There are often more than one way to use these and more than one way to solve a problem. This isn't going to be the neatest toolbox I've ever made. The one in the videos is a little neater than what I'm going to draw with my little Word document here, but we'll figure it out. Okay, so the first rule is the 180-degree rule. And this is for all triangles. And it's the only rule I'm going to put up here that is for all triangles. So when I do this symbol here, that's the triangle shape with apostrophe S, that means the word triangles. Okay, so this particular tool that we have in our toolbox is for all of them. Any triangle, isosceles, equilateral, scalene, right triangles, which is mostly what we're going to talk about. And all it is that if we label the angles, there are 3 angles in every triangle, and I'm going to label them angle A, angle B, and angle C. So this little carrot looking thing here means the word angle, right? So that symbol equals angle. All right, if we add those 3 angles together in any triangle, it equals 180 degrees. That is a very valuable piece of information that we use over and over again. And it's also like the fastest way to solve at least one piece of a triangle. If we know 2 of the angles, we can find the 3rd one really quickly. Okay, so again, this is the only one that's for all triangles. Once we get past this one, now everything else in our toolbox, I have my little cheat sheet that I'm gonna look at to make sure I don't forget anything. Everything under here is for right triangles only. So the next bit of our toolbox will not work unless we have a right triangle. Now a right triangle, I'll draw a bigger one here in a second, always has this little box in the corner or some way that we're supposed to know that it's a right triangle. Everything that we are going to do problems with in this section, every triangle we're going to deal with we can either easily see that it's a right triangle or we can create one. So we'll try to make sure we have enough time to do 2 different ones where it's obvious it's a right triangle and where we have to create our own. All right. Getting a lot of feedback. I don't know where it's coming from. Okay. Okay, so the first tool in our right triangle toolbox, right? I'm gonna put the stars
Is
here.
it from me?
Now,
Heather, is it from me? Mark's asking.
I don't know. I'm gonna see if I can find out. Yeah, I think it was. So I muted him.
Yeah, you know, I'm deaf, so I don't know that there was that noise going on in the background.
All right, cool. We'll fix it. Okay, so the first rule that goes in this section of our toolbox is one you've heard of before, I'm sure. It's c squared, here's the formula, equals a squared plus b squared. And in this formula, notice that there's small letters. A, B, and C are sides. These represent sides of a triangle. So I'll draw a big one here in a second. And this is called Pythagorean. So if you remember Pythagorean from like high school geometry class, this is the Pythagorean theorem. Okay? So the angles up here are all angles. In Pythagorean, it's all sides. All right. But Pythagorean theorem, c squared equals a squared plus b squared is always right triangles. All right, always right triangles only. So it won't work for any other kind of triangle. Okay, the same goes for the next bit that we're going to do here. So I'm going to draw a picture for the next bit. Let's make it a purple triangle. It'll be our MCC purple triangle. Okay, so I'm going to label this triangle now so that it has angles and sides labeled that coincide with what we have in our formula so far. So for example, I'm going to make this angle A and this one up here angle B. And this would be my 90. And this is going to be angle C. So those are all angles, all right? And they're capital letters. Now, I could have also called them like X, Y, and Z. It doesn't have to be A, B, and C, but we're building a roadmap. So I'm going to make capital letters. I've defined that. Capital letters are angles. And now my little letters, A, B, and C, are going to be side lengths. So let me get a different color. So the side that's across from angle A, or the way I think about it is the side that is created by angle A, right? Angle A is this side and this side. So the projected side that's across from angle A, we're going to call little a. So we want the letters that match to be across from one another. So my side B is going to be across from my angle B. And the same with side C, or angle C. Angle C, the side across from angle C, is going to be little c. Now, the side across from the 90 is a special side. The side that's across from the 90, which we've called little c here, is also called the hypotenuse. The hypotenuse is always across from the 90, and it's always the longest side. All right, so C is the hypotenuse. Okay. I'm gonna make this a different color so it shows up better.
You said it was the longest side and that it's always across from C?
Yep, always across from the 90.
Oh,
In this case, we called that angle C, but yeah, it's always across from the 90. So another thing to think about with triangles just in general before we start talking about the trig functions is that the smaller, so C, angle C, which is 90 degrees here, takes up half of my 180, right? So if the whole triangle is 180 degrees, that's angle A plus angle B plus angle C. If the whole thing is 180, 90 degrees of that is already used up by my angle C. That means I have a total of 90 left for A plus B, right? So I'll write that down here. Actually, let's switch back to a different color. Let's do here. So angle A plus angle B have to equal 90. So they have to be a lot smaller than the 90. They're forced to be smaller, right? 90 is the largest angle and it's always going to be the largest angle. That means that the hypotenuse is always the longest side. Then, whichever is bigger, A or B, is across from the next largest side. So bigger angles project or create bigger sides. So if angle B is bigger, side B is bigger. If angle A is smaller, side A is smaller. That's just a visualization skill that helps with this triangle stuff. We can kind of check ourselves. Okay, so now that we've got this little roadmap here, we can talk about the trig functions. So the mnemonic for trig that Mary Bello quoted earlier is this thing called SOHCAHTOA. Yeah.
Yeah, I don't see
All right.
anything now. Okay,
What'd you
see
say,
it.
Juan?
I don't see anything now, but yeah, I see now.
Is it back? Okay, good.
Yeah,
We
it's
don't want to
back.
have that problem again.
Yeah, and I checked my computer and everything. I think everything was okay. So I don't know what's gonna.
Okay. All right, good. We had struggles last time. Okay, so the first part here, so SOHCAHTOA, I know it doesn't really make any sense, but it's just a mnemonic or a memory tool so that we can remember sine, cosine, and tangent. Okay, so the S here stands for sine. So actually, I'm going to move this up a little bit. So the S stands for sine. And the next piece is one of the critical pieces that a lot of people struggle with. The next thing that goes here is an angle. So for example, I might have sine A. All right, color coded a little. So if I do that, what that means now is that I'm going to draw my little stick finger so that I am at the perspective of angle A. So I always draw a little stick figure. It's like I'm standing at A and I'm looking at the other sides and angles in the triangle. All right, so here's our little person.
Is it
So
me?
it is. See, you recognized yourself as a stick figure. So sine A.
Are they celebrating?
Yeah, yes, because they're so excited about trig.
Sure.
I know, right? So this sine function is the O stands for opposite. And the H stands for hypotenuse. The sine function is the opposite over the hypotenuse. Okay, what the heck does that mean, right? So from the perspective of angle A, I'm standing here, I'm looking to see what side is opposite this angle. Well, what side is opposite or across from angle A?
This is the C.
So let me see if I can do this successfully. Ooh. Oh,
Oh, God.
that was
So
good.
the
So we're looking for so here's angle A, right? Angle A is here in green. And if I look across or opposite from where I'm standing,
the little A.
the little a is the side that is opposite the angle A. It's the farthest from me, it's opposite.
Oh,
All right, so there we go. So this is going to be little a here. What's my side that is the hypotenuse? What do we call the hypotenuse? What letter did we assign it?
It was across from the right. So
Mhm.
little c.
Little c. Yep. So the hypotenuse is little c, right? We identified that earlier. So sine A, all that is it's telling us that we're looking at the ratio from the perspective of A of the opposite side, which is little a, to the hypotenuse, which is little c. These are sometimes called trig ratios. That's because that's what they are. It's a ratio of one side to the hypotenuse. Okay, so sine B. Sine B, Again, I'm changing my angle now. So now this is B. Oh, let's not do that. Let's, how about blue? Make it blue. So now I'm B. So I'm going to put a little blue stick figure up here. Now I'm standing up here and looking from perspective of B. All right. So it doesn't change the SO part, the SOH. It's still opposite over hypotenuse. What changes is our perspective. So from B,
It would
what's,
be B over C.
yeah. What side is across from B, right? Across from B, right? The side that's across from angle B, right? Or opposite angle B is little b. So this is going to be B over the hypotenuse, which is C. So hypotenuse stays the same because it doesn't move based on perspective. Hypotenuse is always the hypotenuse. All right, is that making a little sense?
Yeah.
Anybody? All right, good. All right, cool. Let's look at cosine. All right, so cosine, very similar behavior. Cosine is CAH, it's the SOHCAHTOA, it's the ka part. We're going to have two perspectives for cosine also. Our first one is from cosine A. Cosine is, the A stands for adjacent. This is one of the things that sometimes takes a little while for this to stick. So here's what adjacent means. So cosine is the ratio of adjacent side to the hypotenuse from the perspective of angle A, because we said we're going from A. So we're here with our little yellow person, right? So we're down here again. So there are two lines that are next to or adjacent to angle A. They actually create angle A. There's one here, right? And then there's one here. So, but this one up here on the top, what do we call that one? Oops. What do we call the one that's here? This side right here, what are we calling this thing?
The hypotenuse.
That's the hypotenuse. The hypotenuse is adjacent to angle A. It's next to. The word adjacent just means next to. But we're never talking about the hypotenuse when we say adjacent. So this word adjacent screws some people up. Adjacent, whoops. And if I could spell it right, that would help us. Let's try that one more time. So another way to say adjacent is next to. Or part of would be another way to think of it. So the adjacent side is always the side that's next to or part of angle A, but it is not the hypotenuse. So it's the other one. So what side is adjacent to angle A? Is it little a or little b?
Little b.
It's little b. It's little b. So B is the adjacent side to angle A because it makes up angle A. It's next to it. It's actually part of it. It's not across from it, right? We said that the little a is opposite angle A. Adjacent side to angle A is little b.
And then it would be little c, right?
Correct, because we're still in the hypotenuse. Hypotenuse never changes. We know that that's still C. All right. Go back to blue. So now we're from the perspective of angle B, cosine B. Now we're up here, blue stick figure. What side is adjacent to angle B, but it's not the hypotenuse?
Little a.
Little a, right? So it's the same roadmap. It's adjacent over hypotenuse, but we've changed perspective to angle B. So we have our adjacent side now is little a. That's over the hypotenuse. That
That
stays
was
a little
little b. Oh,
adjacent,
It-
right?
yeah, I meant.
Adjacent. Yeah, you
I
said
got
it
it
a
right
minute
the
ago, right?
top.
Yeah, you
Yeah.
did. Got it right the first time. We'll take the first
I
answer.
wrote little b on my paper, so I'm like,
All right. One more set of trig functions. All right. So that's sine and cosine. Last one is tangent. Tangent is TOA. Tangent is opposite over adjacent. Okay. So we have tangent. Same thing happens here. We have tangent of A and tangent of B. So we'll do A first. So we have opposite. Darn it.
and then adjacent.
Yep. This is equal to opposite over adjacent. So tangent function, the tangent trig function is the ratio of one side to the other side, and it has nothing to do with the hypotenuse. So tangent has no hypotenuse in it. So, all right, let's test it. Tangent from perspective of A is the opposite side from the perspective of A. What's the opposite side from A?
No.
It's
It's,
across
little a?
from. Yeah, it's little a, right? Think
It's little a?
across from. Yeah, it's little a, little a. So it's opposite or across from. So little a is my
Adjacent.
opposite side. So that's A. That's over the adjacent side from the perspective of A.
It
So
would be
from-
little b, right? For the
Right.
next one.
Yep. From A, from angle A, adjacent side is little b because it's next to.
And then wouldn't it be and then a and c for the next one? No, no, a and b, right?
Yeah. In what order? In
Or
what
go
order?
b and then a.
Right. All right, let's do it. So
Let's go.
from tangent B, so now we're up here from the perspective of angle B, has the same roadmap. It's the opposite over adjacent, but we change our perspective. Right? So from B, opposite of B or across from B, right, is
Little b?
little b, right? The adjacent from perspective of angle B, the adjacent side or the side next to B
It would
that
be a.
is A. The side next to that is not the hypotenuse is A. All right, so that's all our trig functions. That's our trig toolbox. Almost. We got one more thing. Uh-oh. People need caffeine stat. There's yawning and flopping over.
I've been yawning.
Okay. Is any questions about
No
any of that
coffee.
so far? Oh, yeah, I know. It's too late in the night, right?
Yeah, right. I can't sleep all night if I had coffee now, Mark said.
Yeah, me too. So does anybody have any questions about this piece before I do the last part? Does this all make sense? Just how it's all mapped out, what the word opposite means, what adjacent means?
Yeah. I mean, what you're doing is fine, but I think there'll be more of an explanation. I mean, this is very clear, but once I look at the YouTube video, I mean, it's hard to follow everything right now, but this
Yeah.
definitely helps on top of the other videos. So yeah, it will definitely make a difference.
All right,
I
great.
find it helpful to take a picture of your screen.
Oh, yeah.
Sometimes my notes spread across a couple pages,
Uh-huh.
but
Nice.
it's easy to pull up after too.
Yeah, that's a good idea. I'm going to show you guys something real quick. If you can see this. This is how I have it laid out, right? So you could actually make a Trig Toolbox on one page, or you can take a picture of mine, you know, like Jessica just said. You can make it, you know, this is what I've been like looking, if you see me looking that way, because I'm looking at it going, okay, this is what I put next. And in the videos, I pull that out. Those are my little marker boards. All right. Okay, let's do the last piece and then we'll work a couple of problems with it because it's usually where it
There's
gets.
so many papers to look at. There's so much to do.
There is.
There's so many different formulas, so many different things to look at, but we'll get it.
You will. We will get it. All right. The last piece of the toolbox is what are called the inverse functions. All right. This essentially means that this is our reverse. This is how we reverse the trig functions or undo. Another way to think about it is the undo button. How do we hit the undo button?
Control Z.
Yeah, there you go. Control Z. All right, I'm writing that down. This is Control Z for trig. So up here, we have, typically if we're finding things like a side length of a triangle, which we'll do quite a lot, we won't need the inverse functions. But what if what we want to find is angle A or angle B? If we want to find the angle, we need a way to break apart the trig function, sine, cosine, or tangent, away from the angle itself so that we can solve for it. Similar to what we did with the kinetic energy problem when we moved the 0.5 and the v squared away from the m. We need a way to break it apart. So each trig function has its own inverse function, which looks like this. So we have sine minus 1. This is the inverse trig function. On your calculators, it will say sine minus 1. All right, how it works is if we take the inverse or the sine minus 1, if you want to call it that, of sine A, our angle A from above, what happens is the sine minus 1 cancels out the sine. And what we're left with is just angle A. So this is the undo button. The way I always explain this too is it's like the square and the square root, right? So we could say, let's say 4 times 4, which is equal to 4 squared, right? Right?
Mm-hmm.
That's equal to 16. Well, the way to go back the other direction, the way to undo, is the square root of 16. The square root is the undo button of the square. This thing is undone by this thing.
Okay.
exactly the same as an inverse function undoing one of the functions. This one will make honestly more sense when we use it and we actually put some numbers in there. Okay, so this is true for all the trig functions. So cosine has an inverse function. Cosine with a -1 would undo cosine. I'll just use a different angle, like angle B. That would give us B. And note, we would never do cosine, cosine, or tangent of the 90. So we'd never see sine or cosine of C. It's always going to be A and B. Not the, yeah, the 90. Because the cosine of 90 is 0 and sine of 90 is 1.
Okay.
Which is
I
weird
got it
because
now.
one's a vertical line and one's a horizontal line because of the 90. For
And
more
you-
on that, watch the unit circle videos because that's all in there. Why you get weirdness when you get to the 90. But you can undo the tangent function just the same way. We could do tangent, undo tangent A using the inverse tangent, and we get back to A. These, by the way, so when we get back to here, we would be back in something that would look like degrees. Could also be this funky thing called radians that we kind of dive into a little bit. But because it's an angle, it would be in something like degrees. So that's it. That's the Trig toolkit. Shall we do a couple problems?
Might as well.
Sure, let's do it, right? Okay, I'm going to save this so that if something traumatic happens, I don't have to recreate it. Because that would make
You should name it.
I'm going to. I'm going to call it the Trig Toolbox. Now that, all right. Okay. So I'll keep pulling this up here and there. All right. Has anybody tried the week 5 assessment? Sorry, it's the week 6 the Trig assessment. Has anybody tried it?
Part of it.
So let's do this. We're going to start with something pretty basic so we can get the hang of this. So we're going to start with a practice problem, not one of the assessment problems, but one of the practice problems. And then since Marcus tried it, if he had one of the assessment problems that he wanted me to pull up, I can, or I can just pick one. But I'm going to start here.
Just go ahead and pick one, Heather, and then we'll just go ahead and see.
Okay.
I mean, I just have the one computer.
That's okay.
So yeah, you can go ahead and just show us one.
Okay. I'm at least going to do some that are similar. It's working on it. My computer's just doing a lot right now.
It's being
There we
slow.
go. Give it a break. It's zooming and drawing and canvassing and downloading. It gets a little confused.
Right, it's trying to set up everything.
It's overworked and underpaid. All right, so let's try problem number 1 here. I'm going to snip this thing so that I can draw on it. This is from the practice problems. Okay. So this is pretty basic and it doesn't have like a word problem. Like most of the stuff we've done so far are word problems. And a lot of the problems in the practice and in the assessment are structured that way. This one's a pretty straightforward, this is a triangle problem. I will, when we're done though, talk about this kind of triangle because it's kind of special. So it says, solve the right triangle, and we want to find everything that's unknown here. So we don't know angle A. We don't know angle B because there's no degrees given to us here. We do know side A and we do know side B. So we know that side A is equal to 30 units. We don't know what it is, I don't think. Yeah, it doesn't say inches or anything like that. So it could be inches or millimeters, or let's say millimeters because there's no decimal. So side A is 30 millimeters, side B is 40 millimeters. And we're going to find the two angles and we're going to find the hypotenuse. Do we know what angle C is?
It's 90.
Yeah, it's 90, right? There's our little
Yes.
box. Yeah, so we know what angle C is. So those are the known pieces of information. We know B, we know C, and we know A. We don't know the two angles and we don't know the hypotenuse. Okay. So let's just put this up here, see if I can, how much I can fit on one screen. Oh, exciting. I remembered how to hide the ribbon. So we're just going to walk through. Can you see my Trig Toolbox down here at the bottom of the screen? Okay. Okay.
Yes.
So the first rule we have here, that angle A plus angle B plus angle C equals 180 degrees. Is that going to help us here? We need two angles to find the third angle. Do we have that?
No.
No, we only know one angle. We only know C. So this rule is not going to help us this time. Doesn't mean it never helps us. Just this particular triangle, we can't use it yet. Might be able to use it in a little bit. How about the next piece? C squared equals A squared plus B squared.
That one probably would work.
Seems like it might be promising because we know two pieces of it. We know A and we know B.
Yeah.
So that might be a definite possibility. It's not the only way, by the way, to do this next part. And we'll probably do it a couple different ways so that we can use all the tools and kind of get the hang of it. So let's try this particular piece. Whoops, that's not going to help us. Be nice if I did the whole problem in highlighter, wouldn't it? Be very clear. Okay, so C squared equals A squared plus B squared. Pythagorean Theorem might be incredibly useful. So we know A and we know B, right?
Mm-hmm.
So we could go ahead and we could plug in A and B here. And this time we won't forget to square things. Huh. Learned our lesson on that tonight, didn't we?
Yeah.
All right. So we have A squared would be 30 squared. B squared would be 40 squared. So my C squared, don't lose that little square, would be, let's see, be 900 and 1600, right? Let's all do it.
Yeah.
The same thing. Okay, good. Did you guys get 2,500?
Yes.
All right. So C squared equals 2,500, but we don't want C squared. We want C. Just a little bit ago, I reminded you, how do we reverse a square? How do we undo a square?
You do sine, cosine, or tangent, -1.
Now you're getting carried away.
The square root.
Square root, right? Square root. Go back to our roots. We're
That would
not
be
doing
50.
sine, cosine, or tangent yet. We don't need it. But we have to take the square root to get rid of c squared. That means we also have to take the square root of the other side. This is algebra, not trig. That's why we do algebra first. So we have to take the square root of c squared, which gives us what?
C.
Just c, right? And then we got to use our calculator to do the square root of 2500.
It's just 50.
Oh yeah, it is, isn't it? How handy.
So 50?
Yep, 50.
Yeah.
50. So we got c equals 50. Put that up here. All right. Which means we've also narrowed it down to it's got to be either this one or this one, right? But to narrow it down further, we got to find the angles. Okay. Alrighty, so sorry, I'm thinking. I'm trying to decide if we should do one other thing and come back to this last part. You guys can handle it. You can handle it, right?
Yep.
All right, let's do it. Okay, so now we want to find either angle A or angle B. It doesn't really matter which one we start with. So you guys pick. You want to do A or B?
A.
All right, we're going to do A. Now, the nice thing is because we know all three sides, I'm going to put my little stick figure down here because we're going to look at A. Because we have all three sides, if I go back to my toolbox here, let's just look at this for 1 second. If I know little a, little b, and little c, can you see how all of a sudden, if I know all of these, I know all of these, I have all these values, that I could use any trig function. I could use sine, I could use cosine, and I could use tangent. Does that make sense? A little bit, tiny baby bit anyway, even if it's muddy. If we didn't have them all, let's say we just had, get my eraser. If you don't have all the sides and you only had, let's say we only knew B and C. Well, then only this is useful, only this is useful. Everything else here is not terribly useful then.
Can I ask how we know which one we use, sine or cosine?
It also wouldn't matter here. Good question.
Yeah.
Yeah, so if you knew B and C, what would matter, actually, I shouldn't say that. It doesn't matter because either one would get you something. And in this particular problem, because we're solving everything, but what changes, if you look, is here we're at angle B and here we're at angle A. So if we wanted to solve for B, we would use sine. And if we wanted to solve for A, we would use cosine.
Perfect.
All right, good question. Okay, that makes it look funny, so I'm gonna get rid of that. Okay, so let's go back to what we were doing. So we want to find A, and because we know all of the sides, we don't really have to narrow it down. So you guys pick one. Do we want to do sine, cosine, or tangent? So, ka, or toa?
Wait.
How about sine? That's the first one. We'll just try it.
First check.
All right. So sine is so, S-O-H. Sine of angle A is equal to the opposite side from angle A over the hypotenuse. What is the sine opposite angle A? The side opposite angle A.
Wouldn't it be C?
Opposite across
Oh,
from.
A.
Yeah. And you can always draw the arrow, right? When I draw the arrow, everybody goes, oh yeah, I see it, right? Draw the arrow. I scribble on everything. I sketch, yeah.
Chicken scratch.
Yeah, I do. It's good for visualization. So our opposite side from angle A, only from angle A, the opposite side is 30. What's the hypotenuse?
Little b.
No, what's the hypotenuse?
C.
Oh, C.
C. And what's the value? We solved for it. What was it?
50.
50. Yeah, so that's 50. So we plug 50 in here. So just to be clear, this is little a over little c, right?
Yeah.
Okay, so what we have now is sine A is equal to 30 over 50. We can go ahead and change this fraction to a decimal. That's what I would tell you to always do at this point. So we're going to take 30 and we're going to divide it by 50. What'd you guys get?
0.6.
Yep. 0.6, right? So this is sine angle A is equal to 0.6. Now, here's the hard part. We jumped right into the deep end. I want to solve for angle A, right? To do that, I have to break apart sine from the angle A. I'm going to go over here. Here's my toolbox. Down here at the bottom, remember we talked about the inverse trig functions. If I want to get rid of that sine function so I can just have angle A, I need to use its inverse sine, or this sine minus 1. We're going to find this on everybody's calculator here in a second.
Already found it.
Oh, good. You're like all about this trig stuff. I love it.
What?
You're all about the trig stuff. It's awesome. All right. So we're going to use the inverse sine here. And if we do that to one side, this is our algebra part. If we do that to one side,
there.
we must do it to the other side. So I'm going to move my 0.6 over a little bit because we're going to also do inverse sine of our 0.6. All right. And we actually haven't calculated anything yet, right? But that's what we're doing. So what happens is sine and inverse sine are going to cancel each other out. So we end up with
Just
A is
A
equal,
equals sine minus,
yep,
which
sine
is
minus 1 of 0.6. Ah. Did you already plug it in there? What'd you get?
You want me to let them figure it out?
Sure.
Okay.
We want a roadmap though. So tell us what you got.
Yeah, I need a quick refresher on
Yep. We're going to talk about
plug into the calculator.
yeah, because calculators are weird with this.
53.1.
I got 0.64350110888.
Here's what we're shooting for. 36.86. Now, if you didn't get this, I probably already know why, so we'll fix it. 9, 7.
I did sine
6.
minus sine 1 minus times 0.6.
Okay, so here's what you're looking for. Typically, on a calculator, if I have to, I'll turn on my Elmo, but typically on your calculator, does everybody see the sine, cosine, and tangent?
Mm-hmm.
Just the plain, without the -1, sine, cosine, and tangent?
Yeah.
So then on your calculator, like on mine, I have a second key. You might have a shift key. Sometimes it's the second key, sometimes it's the shift key.
Yeah.
So if you hit shift or second, you should see, if you're using a phone, it'll actually change. On yours, Victoria, I know you're using a regular calculator. It should be on, like, written on the calculator, like above the button that's the sign button. Is that where
It
you found the
is.
sign -1? Okay. So what you have to do is you have to hit your shift or second, then hit your sine -1 button, and then put in 0.6. So we're trying to get sine -1.
Yeah, I got it.
Oh,
That's the
good.
number.
Good. Victoria, did you get it with
I
that?
still get 64 or some
You
reason.
get
I just
So,
You said multiply it,
no, there's no multiplication.
just
You
sine
hit
1
it.
and then 0.6.
Yes. And the only other option is some calculators, you put in the 0.6 first, and then you hit sine -1. That's calculator specific.
Mine hits.
All
Yeah, if you're
right.
using an iPhone, it's backwards. It's second, 0.6, and then sine -1.
Okay. So Victoria,
Mhm.
put your calculator up to your camera. You have to say something so my view will switch.
Wow.
Yeah, there you go. That worked.
You can pin
All
me,
right.
you know.
Well, it won't make you big like I have it on speaker view. So hold it up kind of straight for me. And then up a little bit. No, I don't want the screen. I want the buttons. There's your sign. There's your sign. Okay. So, and then do you see anything on your screen? Because your screen's not very clear for me. Does it say DEG or RAD?
Where would it say that?
Likely in the corner. So tell me what you're getting again. So put in sine -1. Second key, hit the sine -1, and then put in 0.6 and just hit equals. That's it.
I get 64.
Okay. So hang on.
0.64.
Oh, with a decimal, 0.64.
Mhm.
Okay, hang on. Give me 1 second. I'm going to see if you're in a different mode. You are. Okay, you're in radian mode on your calculator. Okay, so there's, this is so hard over Zoom.
I'm going to be in
So-
degree mode.
You want to be in degree mode, yes. So is there a button that has like, yeah, okay, good.
Got it.
Oh, good. Yeah. All right, so anybody
got
who's
it.
on here or watching this recording, if you get 0.6435, you're in radian mode on your calculator, and you have to be in degree mode. Got to be in degree mode. Okay, perfect. It's a good thing you know your calculator well, Victoria, because that was going to be really hard. When I teach this face to face, I always I'm completely egomaniac about never letting a calculator beat me, but on Zoom, it's the challenge. All right, and thank you, Jessica, for letting us know that what the iPhone order is, because I don't have an iPhone. All right,
Because you're
cool.
old school.
Yeah, because it's very calculator specific how you enter it. But once you figure it out and you know how your calculator works, then you're good to go. Okay, let's go back into share mode. Okay, so this is because we're in degree mode, and that's key. Because we're in the degree mode on our calculator, that means that this is degrees. That what we found is degrees. The 0.64 number wasn't wrong that Victoria was getting. It was just radians instead of degrees. I talk about radians in the video. Okay, so that means that angle A here, over here is 36. We have 1 decimal. So 36.9 degrees. Okay. So
Oh, it would be D for right now.
yeah, so we see that this is probably the answer, but let's prove it to ourselves. How could we easily find angle B? What's the fastest, easiest way to find the third angle?
Subtract 36.9 from 90.
Yes, we're going to use, sorry about that. We're going to use this rule that all 3 angles added together equals 180. Right? That's the fastest way. If you know 2 angles, to find the third one's really easy. So we have 180. Or you can start with 90 like Jessica said. I'm just going from 180 so I don't lose anybody. 180 minus the 90 minus our 36.9 that we just found equals 53.1. So that's the fastest way to find that third angle. All right, so then we indeed know that we're looking at D right here. So just a quick note about this particular triangle. This is called a 3, 4, 5 triangle. It's a very special triangle. Gets used primarily in construction quite a lot. So 3, 4, 5, see it's 30, 40, 50.
And isn't there 45, 45, 90 too?
There's a 45, 45, 90, which is very, very special. And then the 30, 60, 90 is the third special triangle.
Yep.
So the 3, 4, 5 is used in construction a lot because if we want to construct something that it has a 90-degree angle in it, like a building, for example, or it gets used a lot in landscaping or deck building. So if I measure, see if I can draw something that makes sense. So if I measure from one point out, and it's any multiple of, we'll use 4 because that was on the bottom. Any multiple of 4 here. And then I measure from that same corner out, and that's 3. Let's say this is 4 feet and this is 3 feet. And then I move the ends until I hit the magic number
5.
5. So when I move these 2 points, I move this point and this point around. When I hit the sweet spot where this is 5 feet, I have guaranteed that that's a right angle. And I can do this in any multiples. So you see here a 3, 4, 5 could also be 30, 40, 50. So 30 feet, 40 feet, 50 feet. Sometimes people will say 6, 8, 10. So some of the construction students I've had will call it the 6, 8, 10. That's just times, everything's times 2. Super useful thing. If you're in the mood to do something fun and you're bored, get out a measuring tape and you can build a little right triangle. The reason it's so useful is I don't need a reference point. Good, take your measuring tape. I saw that, Victoria, and then go out and measure it. You can prove to yourself that it works. Because I don't need a reference point. I can make a 90 in the middle of space, like in the middle of your yard, you can make a 90-degree corner without.
I couldn't smell.
Yeah, you could. And then you could build your deck with a 90-degree corner. All right. That's the 30, or the 3, 4, 5.
Or the 30, 40, 50.
Right. All right. So the angles are kind of wonky, right? We had 36.9 and 53.1, which they're always going to be those angles in a 3, 4, 5, but we don't really care about them. We care about the 90. Okay, let's do one more and we will use straight sine and cosine and tangent to find lengths of sides. That sound good to you guys?
You're killing me, Smalls.
You didn't wear that t-shirt tonight. You can't say that. She has a t-shirt that actually says that.
I will go get it.
Brownie points for anybody who knows what that's from. You're killing me, Smalls. You're too young to know what that is. It cracks me up that you have that t-shirt. All right, so how about we do one of the assessment problems?
Sure,
That'll
why
be
not?
cool. That'll be cool, right? Because that'll help everybody with their assessment. Does that sound good? All right, let me find one. Let me find one. It'll be your reward for entertaining me on a Tuesday night. Okay, give me a minute. Anybody needs a quick break, feel free to take one while I open up the
I
quiz
need a
and
nap break.
find one. Don't take a nap. We're almost there though, Victoria. It's almost 8 o'clock. Okay.
Bye all. Are we done or no?
I'm doing one more problem if he wants to. I'm going to do one of the assessment problems.
Okay.
All right. I'm finding it now. Oh, this will be a good one. None of you will miss.
For the next week, for the next one, or for the ones that they passed?
For the, there's only one left, right? There's only one trig assessment. So, and it's the one that's due March 9th. So it's from that. So it's in this week's module or next, week 6 and 7, week 6 and 7. Does that answer your question, Juan?
Yes.
Okay. All right, cool. All right. This is number 4. We're going to do number 4. Believe it or not, this is the most missed problem, and it's not because it's that difficult. I'll explain why, because you guys are not, you're not going to fall for it. All right. Need a new thing.
Yeah, we lost your picture there
You should
for a
play the
moment, Heather.
Jeopardy theme song.
But you're
Yeah.
back.
Okay. All right, good. Okay, let me share my screen. Why can I not grab you guys? Okay, this is number 4 from this week's assessment. Oh. Can you see it? See a triangle that says BC 6 inches 45 degrees? All right, good. Okay, so it says find the values for B and C, round to the nearest 10th. Answer for B must be entered into the first box, and the answers for C is to be entered into the second box. So this is one of those multiple answer questions. So we're trying to find B and we're trying to find C. So unlike the last problem, it's actually not asking us to find any angles. We're just trying to find side lengths. Excuse me. Okay.
You
For
good?
what we know, can we assume it's a 45, 45, 90 because that square and the 45?
I'm so glad you asked. That's
I think
good.
it's gonna be easier in the long
Yeah.
run.
Yeah. And we're not actually, you could do it using the special triangle. The answer is yes. Yes, definitely. And I'll explain that if somebody missed what Jessica just said. We are going to use the trig functions though, so we can practice it, because you could solve this one a couple different ways. So you can do it however you want, but we'll practice the trig functions. Okay, so what Jessica just said was, hey, we have a situation where we know that this is a 90, right? And the triangle's flipped around on purpose. It's challenging visualization. So I'll talk about that in just a second too. And then we have an angle here that's 45 degrees. Well, using our 180 rule, right? 180 minus the 90 minus the 45 means that the last angle has to be also a 45, right? Even though the problem doesn't ask us to solve for that angle, because it's so quick to do that, you might as well, because it opens up some of the trig function options if we know all the angles. So a lot of times, if you see that you can find the third angle easily, just do it. The other thing on this particular triangle, because this is another special one, is that the 45-45 right triangle tells us something about the two sides and the hypotenuse. So we know that the hypotenuse is big C, right? Because it's across from the 90. So that's my hypotenuse. And what else? I have a feeling Jessica already knows this. What do we know about B and its relationship to the 6 inches? Anybody know? B and 6 inches. If you don't know, it's okay. Okay.
Is the little b?
Yeah, we've been calling the sides little letters, so you could think of this as little b instead of big B. I could call this little b. Here, let's do that.
Okay.
Because you'll see in the assessment and in the practice problems, the letters switch around. You can call them anything you want. We could call it X, Y, Z, right? It could be anything. I just use the little letters and the big letters when I create the first roadmap. But as long as you follow the same system, you can use any letters you wanted to. Okay, so let's use sine, cosine, or tangent to try to help us find what's going on here. Okay, so we want to find the hypotenuse. So we want to find, what do we want to find? We want to find little b. What happened to my drawing tool here? We want to find little b. And we want to find C, which is also the hypotenuse. We want to find the length of the hypotenuse. Okay? So that means that this, if we use the same labeling strategy we've been using, that would be A. All right? So what do you want to solve for first, B or C? It does not matter. All right, we'll go with B. So to
Let's go
solve,
for small b.
all right, good. Oh, good, we're in agreement. So if we want to solve for small b up here and put a little star by it. I have all the angles, and the other thing I know is that A is equal to 6 inches. I should write that down. I know that A is equal to 6 inches. So I need a trig function. If I want to solve for little b, I need a trig function that uses little a It uses an angle. It could use either angle A or angle B. It wouldn't matter because we know them both. And actually, let's go ahead and label those as well. This would be A for a little roadmap we've been using, and this would be angle B. It cannot use the hypotenuse. All right, so we need a trig function that does not use the hypotenuse because we
It would be
don't know
tan-
the hypotenuse. What was that?
It would be tangent, right?
It would be tangent. Let me pull up the toolbox here. So if we think about it, we don't know the hypotenuse. So what that means is anywhere we see hypotenuse is useless. So these sine and cosine won't work. Now here's what I always tell students. What's the worst thing that happens if you tried sine or cosine? Nothing happens. Just try one. And what you would find is you don't have enough information, and then you'd go try a different one. Just like tools, right? Tools in a toolbox. You take a screwdriver out and you try to use it with a screw, and you find out what you needed was a Phillips, not a flathead, and you go back and get a Phillips.
I mean, you could use a flathead.
You needed a flathead and you grabbed a Phillips. Smarty pants. So you had a Torx head and you grabbed a Phillips head. I'll get complicated if I have to. So, but you might get what I'm saying, right? You just go find the right tool because you figured out that the one you grabbed wasn't the one you wanted. No big deal. But we can see that down here, tangent uses the sides, opposite and adjacent, no hypotenuse. So if we get kind of handy with this, we can always grab the right tool more quickly, essentially. All right, so we're going to use tangent. Okay, so tangent, if we want to solve for little b, here's a quick thing to think about. Does it matter if I do tangent of angle A? Does it matter if I do tangent of angle A or if I do tangent of angle B? What do you think? Let's do both. If you're not sure, we're just going to do both. So tangent is TOA, opposite over adjacent. No matter where, no matter which one, A or B, it's still opposite over adjacent. It just changes based on perspective. All right. So I'm going to put my stick figure by angle A. I'm standing here at A. What is the opposite side from angle A?
Little a.
Little a, yes. This is little a. What's the adjacent side to angle A that is not the hypotenuse?
Little b.
Little b. Yep. All right. So tangent from the perspective of angle A is little a over little b. Let's look at tangent B. Now we are, let me switch colors. Now I'm a blue stick figure. So I'm from the perspective of B. I'm standing right here at B. What's the opposite side from angle B? What's across from angle B?
Little b.
Little b. What's the adjacent side from angle B?
A.
Little a, right? Because it can't be the hypotenuse, so it has to be little a. So we see again that tangent A and tangent B are just the inverse of one another. It just means we flip it over and we have the other one. So the known information that we have is the 6 inches. So my tangent A would be A over B. Going back to my purple. Right? So my A would be 6 inches. And my B would be on the bottom. For the tangent of angle B, it's just going to be the reverse, the inverse of it. Which means it's flipped over. It's going to look like that. So we could use either one. So now we do the one last thing that I wanted to make sure we did tonight is we need to plug in an angle. Well, tangent A and B, right? Either angle is 45 degrees. Because this is a very special triangle. All right, so that means that I have tangent 45 degrees. And let's do, we're going to do both of these because I'm going to show you how to solve either one. I'm going to show you 2 different ways to do this. All right, so tangent 45 degrees up here is 6 inches over B, right? Stop me if I lose anybody. All right, now at this point, you can do a couple things. I'm going to write the same thing over here because I'm going to show you 2 different ways to do it. And you're going to pick whichever one of these speaks to you. I don't care. This has to do with whether or not you like algebra or algebra is not your friend and you would prefer to not do algebra. These are the same thing. This side, if I have tangent 45 equals 6 inches over B, I want to solve for B. That's what I'm trying to do. Trying to solve for this thing right here. So in the first one, it takes 2 moves if you use the algebra method to solve for B. So the first thing we have to do is we have to get B to not be on the bottom. It's on the bottom of a fraction. So we could multiply by B. And if we do that on this side, we must do that on this side. What happens to B on the right?
Yeah.
It cancels out, right? Because you have B over B, because we moved it to the left. The other way to think of this, again, is to swing it. This is a 6 divided by B, so if we swing it to the other side, it becomes a multiplication. So now we have B times our tangent 45. At this point, let's do this in our calculators. I can get rid of the tangent 45 by using my calculator and putting in just your tangent function with 45 degrees behind it. Just make sure you're in degree mode, not radian mode, or you'll get a weird answer. So tell me what tangent 45 is on your calculator. Sorry, I missed that.
1.
With a decimal behind it, right?
Yes. So it would
Yeah,
be
like-
1 point.
I'm going to put a bunch of them up here because I want to make sure everybody's getting their calculator to calculate tangent 45.
What number is that?
That's tangent 45.
I didn't get that number. I just got a
Oh,
regular old one.
no, hang
Yeah.
on. I was in radians.
You
Yeah,
said
you
not to
scared
be
me.
late.
I was thinking that I'll do it wrong. So,
I should have known too, because there's an obvious reason why that's wrong. I was just testing you guys. I was messing with my calculator earlier, trying to figure out where the radian degree button was, and clearly I pushed it. Okay, sorry about that. Sorry. Dang it.
I was like,
You were like, that can't be right.
exactly.
All right. Okay, so tangent 45 is indeed 1, just the number 1 all by its little self.
Yes.
Okay, so we got 1 here, and that's equal to 6 now, right? So we got b times 1, which is just b, right? So b equals 6. All right, so over here, another way to do this, if moving all this stuff around, if you don't like it, you could create, so I wrote the same thing, tangent 45 equals 6 over b. And I just put the tangent 45 over 1. If back when we were doing cross multiplication, if you like cross multiplication, that's what this becomes. Now I can multiply 1 times 6, and I can divide by the tangent 45 number, and I'll get b, which is essentially what we just did. So I'm going to write that down. I could take 1 times 6 divided by tangent 45. Magically, we'll get b, and we'll also get 6. All right, so all we're doing is creating a proportion there. So if you like that method better, you can do whichever one of these you like. Doesn't matter to me.
So B would be 6, right?
Yep, b is 6. Now, if we recognize that this is a 45, 45, 90, 45, 45, 90 right triangle, the two sides are always equal. So we could have jumped right to, hey, I know this is a 45, 45, 90. That's got to be 6.
Yeah.
Right? We could have said, I don't need trig to solve that side of the triangle. I already know what it is.
And then wouldn't you take 90 minus 45 to get C?
No, that's just for the angles. Don't get crazy.
You could do a squared plus b squared to check c squared.
You could totally do that. You could use Pythagorean on it at this point and use c squared equals a squared plus b squared like we did before, and you could find c. Or for our grand finale, we're going to use, that would totally work though. Because we did Pythagorean earlier, we're just going to do one more trig function. So if we were trying to find the hypotenuse, we want to find the hypotenuse, what trig functions would we think about using? Let me ask it this way. Could we use tangent to find the hypotenuse?
Yeah.
Do we see it anywhere? What were you going to say, Juan?
We gotta do in the same thing, like c equals 6 and square plus 6 and square to find the other one or no?
You could totally do that. Yeah, that would work. Or you could use a trig, you could use cosine or sine. All right, we couldn't use tangent because there's no hypotenuse, there's no c anywhere in the tangent function here. But sine and cosine both have the hypotenuse in them, so we could use that. Or just like you guys pointed out, we could use c squared equals a squared plus b squared. Any of those would work for this section. Part of the reason we have so many options is because it's the last thing. We've solved this entire triangle with the exception of c. So we have sine, we have cosine, we have Pythagorean theorem. Any of those will get us c. That's why we have so many options.
So 8.4?
I think it is, yeah. So I'm going to triple check so that I don't tell you something wrong.
Like you did earlier?
Like I did, I switched 2 things around in blueprint reading the other night, and Jessica knows how bad that is. All the worksheets we have in there, I switched 2 things around and We had the right answers, but one was like number 1 in the assessment and the other was number 2. And we figured it out before everybody left. I thought, oh God, that would have been like 700 emails.
Like, what? Why did I get the answer wrong?
Right. What did you do to me? Okay, so here's the thing on this question. Here's what is the most missed part on this question. Yeah, a second. Gotta find where I was at. There we go. The answer says, or the question says, give your answers for B and C with 1 decimal. What is
So-
the answer for B with 1 decimal?
It would be 6.0, right?
Yes, it would be 6.0. You guys are ahead just because of that.
And then it would be 7.8 for the next one, right?
I don't think so.
I don't know life.
Hang on. We're going to make sure everybody knows by the end of this tonight. Nope. And actually, Juan, you rounded a little funny. All right, let's do it. We're doing
Can
it.
you please? My brain is fried.
We're
So
almost
this
done.
not, so this not 8.4?
No,
What?
8.5.
8.5.
At the
8.5,
start.
Juan.
Oh,
Yeah,
yeah,
some-
because we have 1A in front, sorry.
You rounded the wrong way,
Yeah.
right?
Dun,
Here,
dun, dun.
we'll do it real quick.
Dun,
Whoops.
dun, yeah, you're right.
I have a hard time with them sometimes. Rounding, trying to figure that out.
Yeah. Yeah.
The smaller they get, or the more decimals, the tougher it seems to be sometimes.
Yeah, because you gotta find your way through all the numbers. So C squared, did you guys all use Pythagorean theorem? Is that what you used? Jessica, is that what you used too?
Yeah.
Okay.
Yeah.
All right, so we got C squared here. A squared would be our 6 squared, right? B squared is just 6 squared again. So what'd you get here?
72.
And then how do we reverse the square?
Square root.
Square root, right? Make sure everybody's on the same page. And then what do we get for the decimal? Whoops. All right, so this gives us 8.485. So if you round up, right? Gotta round up. Ooh, all of a sudden there's a bunch less people.
They said
Because of
bye.
the Oh, they did? I missed
They
it
waved.
completely. All right. So
You just focus
8.5.
on the C.
Yeah. They were over us, apparently. Okay.
I am over this too. It's
Oh, wow.
2020.
Well, at least you got one assessment problem done. So that's good. Yeah, it's 8:20. We're done 10 minutes early, 9 minutes early. It's
It's
8:21.
2021
What do you mean it's 2021?
The time.
because the military time is 28 is 20.
Oh, I was.
You're a math
I
teacher, so
meant
you
the
should know this.
year. I thought you meant the year 2021. I was not
I mean,
thinking
it is
military time.
2021.
I am a math teacher. What does that have to do with military time?
You know how to do it.
All right. Does anybody have any last questions for tonight?
Can I go to bed?
Nope.
You can. So
Thank
next week
you.
during the Zoom, I'm going to send an email out to everybody so everybody gets this message, but I'll talk about the final project and I'll answer any questions about the last assessment, the Trig assessment. Okay.
The twig.
That's what we'll do next week. All right. Have a good night.
Bye. Thanks.
Thank you.
Bye. Thank
Bye.
you.
Wait until you kick me off.